Let me take the same example as given in lead code. I will take this and use it here. And let me first of all separate it out with nums and index. So what I mean is start with I and nums I. So this is our nums array. Now let's start solving this problem using the bottom up approach. So for example, we'll start from the last index here. So suppose we are only given this an array of one element and containing only whatever number is there. For example, here it's given as 4. It can be any number, 1, 2, 3, whatever. So it means that our start position is same as our target position, because we don't need to jump anywhere because we are already at the target or the final position that we want to go. So for any index, if any array is given with only one element, so it's always going to be returning as true, because the starting position is same as the final position. Whatever the number is there, it doesn't matter. For example, it's like 1, 2, 3, 4, whatever number is given here, it doesn't make any difference, because we don't need to jump anywhere from here to the next element, right? Because we are already at the target position. So it means that for any nums array containing only one element, it's always going to return me as true, which is our base case. So if I indicate this as my target index is 4. We don't care what's the number there, but we just care about the index here. This is our target. So we start target with I is as 4, which is our target at this position at the final index. So if we say that we started with the index 4, the last index, so it's always true. So I will move from index I is equal to 4 to index I is equal to 0. And we will see that once we reach to 0, whether the target is still true or not. If it's true at this index, it means that this is a final solution that we can return as true. So let's go to index 3. So if I treat index is equal to 3, right? So what I mean is that we are given only a nums array containing these two elements. And this is our target position. And this is our initial position, starting position. So here, as the problem statement says that, right, that number is given as 1 here, which means that it can make a jump of 1. And doing so, by making a jump of 1, we can always reach the target easily. I mean, it's possible to, so it's going to be written as true for I is equal to 3 as well. So this would be also true. Now, there is one important thing to understand here is that now for the whole problem statement, instead of, so our initial target was to reach to this index of 4, right? We had to reach for 4. But now as we solved that, even if we reach from 0 to 3, right? Index of 3 is also giving me true, because if we are able to reach from 0 to 3, we've already solved that from 3, it's already possible to reach to the target position of 4. So now our target position can be changed from here to here for the rest of the problem statement. I mean, the sub-problem which is left here. So for the sub-problem here, we already see that if we are able to reach from 0 to 3, and we already know that from 3 we are able to reach 4. We have already stored this value as true. So it means that our problem has been divided into sub-problem, and our new target right now is 3. So in the same way, we are going to proceed for 2, 1, and 0. Now let's go with I of 2, which means that we are given this sub-array or a sub-problem. And we already noticed from our previous sub-problem that our target has moved from 4 to 3. Because if we are able to reach 3, it means that we are already able to reach to 4 using this sub-problem result. Now again, if we look at this, I mean, if you are at starting index here, we see that the number is given as 1, which means that it's possible to jump off maximum 1 position and reach our new target position here at index of 3, which means that this is also true, because we have already solved that from 3 it's already possible to reach to our initial target, final target destination of 4. Now let's go to index 1, which means that now we are looking at this subarray, and as mentioned in the previous subproblem, that our new target position has moved from 3 to 2, because if we are able to reach 2, we are able to reach 3, and if we are able to reach 3, we are able to reach 4, and 4 is our final destination. So here our subproblem states that if it's possible to reach from index 1 to index 2, then it would be already true. And here at index 1, again, we see that the number is 3, which means that there is the possibility of jumping from this position to 1, 2, or 3. So there are like 3 jumps possible. So if we can jump, if I just choose 1 jump, I mean, out of 3, I mean, we can jump 3 here directly to this position, or have a jump of 2 to move to 3, or only if we choose 1, because our new target has been revised as 2 now. And now it's possible to take only 1 jump and reach to this destination, which means that this is also true. So even for I equal to 1, we are able to reach to our new target destination of 2, and that's why it can be also marked as true. Now guys, before we proceed with the final solution for I equal to 0, based on all the bottom-up paradigm dynamic programming approach as we have solved in all our previous problems. So here, first of all, we are seeing 2 patterns first. That first of all, we are dividing this whole problem into sub-problems. And this is the first thing. So we started from I equal to 4, and then we just took the subarrays, and we were able to calculate whether it's possible, like true or false for that particular subarray or not, right? And here we also saw that because we are changing our target positions from here to here, and then for the next case, we are only checking that, or we are reusing the results that we have already calculated for the previous subproblem. For example, for I equal to 2, for example, say I equal to 3 when we are here, and we solved that it's possible to reach from 3 to 4. We change our target from 4 to 3, right? And when we calculate for I equal to 2, our new target was already just from here. We don't need to check whether we need to reach to the final destination. We can only check whether we can reach to the result of the previous subproblem. So these 2 patterns, let us consider that this problem can be solved using the dynamic programming bottom-up approach. These are the 2 very important things to identify when we are solving any type of dynamic programming problem.